Elevators, real quick, elevators. It's just, there's nothing really new. It's just a different situation. If the elevator is sitting still, and you're in the elevator, what are the forces on you?
Gravity, natural force.
Gravity.
Normal force.
And
Normal force.
I'm going to draw it over here because I don't want to slice the person. Fn. And if the elevator is still, or at, I'll say at rest, not moving, these two are
Equal.
good, equal. If the elevator moves up, accelerating up, what happens?
Normal force is greater than gravity.
Notice we're talking about the forces on the person, not the forces on the elevator. Those are a bit different, right? What is the force pulling the elevator up? You just learned about it. Tension. Good. Easier. It's a cable pulling the elevator up, right? So you have tension. But we're not worried about that. We're worried about in here. Does gravity on you change?
No.
No.
No. Stays constant. So this equals. What happens to the normal force? Increases. So, if the scale here, if you're sitting on a scale, and let's say your scale is like here, that's your mass. What will the scale say over here?
You'll be heavier.
Good. Your scale here is going to be like this. Does your mass actually change?
No.
No. So a scale doesn't measure mass, it measures the normal force, right? So if the elevator's pulled up, you're going to squish the scale, and it's going to read you heavier. Only while you're accelerating. Kai, what did I just say?
And you're accelerating up? I wasn't quite listening.
Only while you're accelerating. Say that again.
Only while you're accelerating.
Good. What happens when you stop accelerating and you're moving up at a constant speed?
Then you're balanced.
It's exactly the same as when you're at rest. You have no way of telling the difference. Okay. Constant velocity. What about if you fall down?
Die.
You die. That's morbid.
Force of gravity is the same. but the
Okay, good,
normal-
yeah.
It's small. The normal force, wouldn't the normal force just be the opposite?
So your force of gravity is not going to change. But what do you feel?
Your stomach going up.
Yeah, you feel like your stomach's going up because your stomach has inertia, right? So this is accelerates down. These are three different situations. So if your gravity doesn't change, then how are you suddenly being pulled down? Kai,
Because there's a lack of the standard force.
normal force.
Normal force.
Good. So your normal force goes from the same as gravity to
0.
0 or less than gravity.
Yeah.
The fastest you're going to accelerate is 9.8, right?
Gravity.
Yeah, but we're just talking about.
So this scale here, what would this scale read if you were on it?
Lighter.
It'd be lighter, right? This is, if you don't understand, this is a dial of a scale. And if you're standing on the scale, it's going to read you as being a lower mass, but you're not a lower mass. You're just accelerating downward. So your normal force is less. So what you see on a scale is the normal force, not your actual mass, or even the force of gravity. So Taylor, repeat after me. In an elevator,
In an elevator,
gravity does not change.
gravity does not change.
only the normal force changes.
Only the normal force changes.
Good. Everyone else needs to remember that too.
Yeah.
So that's how you figure out all these elevator questions. Okay. Also, Newton's third law. This is from the previous video from Ainsley's problem and others that were asking about this, which is a little bit higher level, which will not be on the quiz, but interesting nonetheless. Newton's third law. I'm going to do it in less than a minute. Oh, Asia, yes.
But, do we have a test on Monday?
Friday.
So we have a quiz on Friday, but no test?
Quiz on Friday for Newton's laws. And I haven't figured out the test yet. I will tell you soon.
So like the tension question, will that be on the quiz?
Yes. That's part of Newton's laws. Hold your hands like this. Oh, I wasn't thinking that, but we could. Take this hand back. Relation. Is the force on the... Which force is greater? The force on the moving hand or the force on the hand that gets hit?
Force that gets hit.
Here's another question. You have a fly. Flies buzzing around. Very happy. Flies only live for 24 hours, so they better be happy, right? Just flying around. I'm gonna go and I'm gonna find this like other fly, and we're gonna have a party, and you know. And then it doesn't realize it, but it flies over a road, and on the road are big trucks, big moving van, and a moving van comes, and the fly's like, nice sunny day, and the moving van comes, whoom, and the fly is now part of the windshield. Is the force greater on the fly or on the van?
Well, the force of the van is greater.
The truth is, it is the same. The force on the van and the force on the fly is the same. How can that be?
Because of Newton's law.
It's a strange truth about our universe that Isaac Newton realized. Through observation, he kept questioning about things. And what you want to say is that the fly experiences a much greater force because the fly accelerates, right? It goes from just kind of sitting still to moving really fast. The van doesn't slow down at all. Or does it?
Incrementally.
An immeasurable amount.
Okay, you probably would have a tough time measuring it, right? But let me ask you this. If we didn't have a fly, if it was a rhinoceros or an elephant, let's say you took an elephant and you tossed it in front of a moving truck, would the truck slow down?
Yes.
Yes.
Yes, absolutely. It would slow down a lot. What if you took a seal, like a walrus, and you threw a walrus in front of the truck? Would the truck slow down?
Yes.
Definitely. What about a baby deer?
Yes.
Oh.
Bambi. Throw Bambi up. Would the truck slow down?
Yes.
Okay, a basket of squirrels.
Probably not.
Throw that in front of the truck.
This would be bumpy, but
So the question is, if the fly does not slow down the truck at all, then there must be a line somewhere between the elephant and the fly where that truck goes from slowing down a lot to not slowing down at all. Isaac Newton observed that there is no line. The truck does slow down when it hits the fly. But it's such a small amount that you don't notice it. Net force equals what?
Times acceleration.
Mass times acceleration. So force equals mass times acceleration, right? Is the fly's mass big or small?
Small.
Very, very little small. And it experiences a big acceleration. Yes?
Yes.
This is for the fly. Fly's force. For the truck, does it have a small mass or a big mass? Big mass. And so, it's going to experience a teeny little acceleration. The product of these two are the same. So if you have a big mass, you're going to have a small acceleration. If you have a small mass, you're going to have a big acceleration. But when you multiply the two together, you're going to get the same force. This is so weird. There's no unbalanced forces in the universe. Force is in balance, no matter what Darth Maul says. Thanks, Azia. You're the only one. Think about this. There's not a lot of problems that I can give you for this, other than is the force bigger on the truck or the fly. But do think about this, and the elevators will also. I'm going to give you some practice on the elevators, and then we'll talk about your